This will be the beginning of bringing data into Elasticsearch. First, we need to stand up Elasticsearch. So let's go to the Elastic website and download Elasticsearch for your specific platform. I'm on a Mac, but if you are using a different operating system, it shouldn't matter. Download the specific one for your platform. Once you've downloaded it, extract the archive using tar. Once it has been extracted, change into the directory. From here, we need to make modification to the configuration file for Elasticsearch. You can use any text editor. I'll be using VI, but you can use Nano or even TextEdit if it's easier. We're adding the network host of 0.0.0.0. Discovery seed type of single node because we'll only have one node of Elasticsearch running. And setting the seed host for the single node. From here, we'll save the configuration file and start Elasticsearch. It'll take a few minutes to get started. This is only a delay the first time you start it. After this, the startup will be very quick. It's ready to start when you get an error notice or warning notice down here about security features not being enabled. Don't worry about that. We'll enable that later as we go. Next, let's test to make sure that we can access the application programming interface of Elasticsearch using curl. The default port is 9200, and we'll simply curl that to see that we should get a response back from Elasticsearch. Elasticsearch responds back with its version and various other information about it. Next, let's create our first index. We can use the curl command again to interact with the Elasticsearch API to do so. We'll see a response back, acknowledged equals true, that it created the index called my first index. Next, let's check the indices to see what indices are available. We should see the one that we just created. As you can see, my first index has been created and is the only index currently inside of Elasticsearch. Next, let's check the health of all of the indices. Using the v equals true for verbose output shows us the status of all of our indices. Currently, as we discussed about earlier, we only have one, my first index. Next, we'll work on sending data into Elasticsearch using beats. Now we're going to download Filebeat and configure it to send some sample data into Elasticsearch. First, we need to download Filebeat, and we can do so from the Elastic website. I'm going to be downloading it for Mac, but any of your particular operating system platforms would work. Once we've downloaded it, we'll extract the archive. Browse into the new directory and modify the YAML file for the configuration of Filebeat. I'll be using VI, but any text editor should work. The only change that we're going to do is down under the inputs, we're going to change it from false to true. And we're going to leave this default directory of var log to ingest my log files from my Mac. The Elasticsearch configuration won't need to be modified. Next, we need to validate that Elasticsearch is up and running so that we can send our log data into it. If you don't have Elasticsearch up and running, start it the same way that you did previously with using the bin command in the bin directory. So I'm starting Elasticsearch back up, running the Elasticsearch binary in the bin directory, giving it a few seconds to come back, and then we'll test our connection. Just like we tested before, I'll check the local host on port 9200, which is the Elasticsearch default port, and I can see that my cluster is back up and running. Next, let's check the output of Filebeat to validate that it can access Elasticsearch properly. Again, it gives a warning about the TLS and others, but we will configure that as we go forward. Now that we know that it's up and running, let's go ahead and start Filebeat officially and send some data into Elasticsearch. Similar to how we tested for the my first index, let's check to figure out what indices are now in Elasticsearch. Unlike when we first checked to see my first index, we now see a Filebeat index in there. Let's check to see exactly what is in the Filebeat index. We can use the curl API, the Elasticsearch API using curl to get the data that's out of there. This will be the last time that we do this from the command line. Going forward, we'll use Kibana to interact with the data in Elasticsearch. We need to pass it the proper index name, which is right here. And a search API. And here we can see all this information that is being absorbed by Elasticsearch from my var log connections. We'll go ahead and stop Filebeat now, and we'll look at some of the Filebeat modules that we can use. Modules are a way to set specific data pre-configured into Elasticsearch. Here we can see all of the different Filebeat modules that are available to us. None of them are currently enabled, but we can enable them for the system module. If we look now, we can see if we run the modules list command, we can see that the system module is enabled. Let's restart Filebeat and then move on to look at data with Packetbeat, which is network data. Next, we're going to download and configure Packetbeat to send data into Elasticsearch. On the Elastic website, to download Packetbeat, simply click on My Version and download that. If you're using Windows, you will need to use npcap, and the instructions to do that are on Elastic's website and also in the book. After we've downloaded the archive, we need to extract it and then browse into that directory. Next, we need to check which device Packetbeat will be listening on, which interface. And to do that, we can use Packetbeat to list all the known devices. As we can see, my device EN0 is the one that has an IP address and should be the one that we'll be listening on. Next, let's look at the configuration file and modify it with our network device. By default, Packetbeat selects the first network interface, but you should check to make sure that this is accurate. For me, this is exactly what it needs to be. Let's test to make sure that the configuration for Packetbeat is correct. Also, let's check to make sure that it can access Elasticsearch. If Elasticsearch is not accessible, start it using the bin directory and starting the Elasticsearch program. As we can see, Elasticsearch is already running. Again, if you need to start it, Elasticsearch has a program in the bin directory of the Elasticsearch folder. Finally, let's go ahead and start Packetbeat and then send the data into Elasticsearch. Just like before, let's check to see what indices are now created inside of Elasticsearch. As we can see, we see my first index, which we already created, Filebeat, which we created, and then also now a new one, which is Packetbeat. Packetbeat can also ingest previously collected PCAP files. This is really helpful if you're provided them as part of a threat hunt from data that was collected before you arrived. To simulate this, we'll use the TCP dump program as an example to collect a small amount of packets from my machine and then ingest those into Elasticsearch using PCAP. I'll be saving this file as local-capture.pcap. Now TCP dump is collecting information on my Mac. I'll let it run for a few seconds and then I'll collect it, stop it, and then use Packetbeat to ingest these PCAP data directly into Elasticsearch. As you can see, I collected a small amount of packets, 154, just enough to use as an example. From here, I can use Packetbeat to ingest this PCAP file. Once Packetbeat has finished sending all the data into Elasticsearch, it'll stop running. Next, we'll be connecting Winlogbeat data into Elasticsearch. Unlike all other beats, this obviously has to be run on Windows. So from a Windows system, we'll simply download the zip file for your architecture. We'll extract the archive. And unlike previously, we will have to make a change to where this sends Elasticsearch data because as we have previously shown, it's running on my Mac, which is on a different system, obviously. So it has a YAML file similar to all other beats. We'll simply modify this using Notepad. And scrolling down to the output section, currently it says output.elasticsearch host localhost 9200. We want to change that to the IP address of where I'm running Elasticsearch, which is 192.168.1.174. Your IP address will be different. We'll save this file. And then we'll test to make sure that Winlogbeat can access Elasticsearch. We'll do this from the command prompt. As we can see, we are able to connect to Elasticsearch. So let's go ahead and start Winlogbeat up and make sure that the configuration file is up to date. And then finally, let's create the Winlogbeat index. Just like before, we can curl Elasticsearch to see the new index that has been created. You can see we now have Winlogbeat as an index in Elasticsearch. Next, we're going to be using Kibana to interact with the data it stores out of Elasticsearch. Doing it from the command line is a great way to test to see if it's working. However, it doesn't scale when you're looking at large volumes of data. So we'll use Kibana to do that. Again, go to the Elastic website and download Kibana. I'm using my Mac, so I'll use that as my operating system. As before, once it is downloaded, extract the archive using tar. Once the archive is extracted, browse into the directory, and there is a configuration file that we need to modify to allow external access to Kibana. We need to change server.host to any IP address. We can do that with 0.0.0.0, meaning anyone is allowed to connect to our Kibana instance. Finally, let's go ahead and start Kibana and then connect to Elasticsearch with it. By default, it will look locally on the default port of 9200, which is where everything is running. The default port for Kibana is 5601, so while that's coming up in a browser, we can browse to that. It may take a few seconds for it to come up for the first time, and once it does, we should be at the Kibana landing page. You may notice down at the bottom your data is not secure. This is a great banner to warn people that we are interacting with Elasticsearch, Beats, and Kibana in a way that is very insecure. There is no authentication, it's not over encrypted channels. It's really good that they warn about this. We're doing this just completely as a demonstration. We'll work on securing Elasticsearch as we move forward, but we can hit dismiss for now, but it's good to know that this is not a secure deployment. This is simply to do a walkthrough of the different parts of the Elastic Stack. First, we're going to go to the management page and add the indices, create index patterns for those so that Kibana can render that data. We can access that a couple of ways. We can either click on this management cogwheel button, or we can use this hamburger menu and go all the way to the bottom and click on Stack Management. I prefer to use the flyout, but you can do it however you want. Once we're on the Stack Management page, we first want to go to the index patterns, which is how Kibana visualizes and renders the data inside of the indices. So if we click on index patterns, it'll say that you have data in Elasticsearch, but you need to create an index pattern. So to do that, we just click the button. We now see all of the different indices that we've created. If you remember, Filebeat, Packetbeat, Winlogbeat, and my first index. So what we want to do now is we want to create a index pattern for this. So let's start by using the Filebeat index. Simply, we do this with Filebeat -*. By default, this is the naming structure that is used for beat data when it goes in. The beat name dash the version dash the date. And so when we do Filebeat -*, it will get all the Filebeat data irrespective of what version or what data was ingested into Elasticsearch. Next step, it's going to ask us, what is the date for this? By default, app timestamp is the time field, and we can go ahead and select that. Next, we can create the index pattern. Very simple. Now it's created. Let's go ahead and do the same thing for Packetbeat and Winlogbeat, and also my first index. So to do that, we'll do the exact same steps. It should be noted that my first index, we only created as an example. There is no time field, but we can create it without it. Finally, we can see all of our index patterns that we've created. Filebeat, my first index, Packetbeat, and Winlogbeat. Next, let's go into the Discover app so that we can see all the data that we're looking at. Again, clicking on the hamburger menu, we can click on Discover. Over on the left-hand side, we see all the different index patterns that we have at our disposal and different parts of Discover. This is the search bar. It is where you'll do all of your different searches and queries. This is the index pattern selector, and this shows you all of the different index patterns that you have. As an example, I'll select Winlogbeat and a time of last 24 hours. And we'll see all the data that we've ingested from Winlogbeat. Down below, this are the available fields that we have that are representing the data that is inside of Elasticsearch for this index pattern. Here we have the query language, whether we're going to use the Kibana query language, and we'll talk a lot more about that later, or Lucene. For time series data, we have the time picker, and this allows us to select commonly used times, or we can even use very specific time fields if we want to get absolute this date and this time is when I want to start and stop. Or we can use the commonly used ones. This is your time series visualizer. This shows how much data is ingested over the time that you're looking at. As we can see here, there were 162 events over this date, which was approximately just a few minutes. Down below, we can see all of the results. These are a representation of all the data that is inside of Elasticsearch in this index, and this can be focused and filtered down, and we'll explore more how to do that as we move forward. Moving on to the security app, Moving on to enterprise search. This is an app that Elastic provides, again, for free, that will allow you to make multiple connectors from inside of Elasticsearch into different providers and allow you to search inside of Elasticsearch and Kibana, all of those other locations. As an example, you can make connectors into Dropbox, Google Drive, GitHub, and it will allow you a single place inside of enterprise search to look for data that will reach out to those other sources that you have and return the results inside of Kibana. We also have observability. Observability is a way that you can use beats to store data and represent data about uptime, how your different platforms are behaving, and what kind of metrics they could be having, additional how users are interacting with it, click-throughs, how much time people are spending on pages. Observability is a very, very powerful app and is one of the big ones that Elastic uses. However, it's outside of the scope of what we're going to be doing for our discussions. Finally, we have the security app. We haven't sent any data from Elastic agents in yet, so there isn't a tremendous amount of data inside of the security app for us to look at right now. But just as a high-level overview, this is an overview page that you would land on that would show different alerts from internal and external, the different types of events that you have. As an example, host events can send AuditBeat, Elastic Endpoint, Filebeat, and Winlogbeat data. Different types of data that we've sent in from Packetbeat, and as we can see, if we click down on the Packetbeat data, we can see what type of DNS flow data and transport layer security data, SSL data, is present inside of our very small PCAP that we collected. Moving on to detections, again, we won't have anything in here yet, and we haven't configured the security, so there will not be anything that we're able to view here because the permissions haven't been configured yet. But we'll get into that as we move forward. The host section allows us to get an overview of the different hosts that are reporting in. Authentications, processes, external alerts would be provided from intrusion prevention systems or network security monitoring platforms that have some sort of signature detections such as Suricata or Snort. This is the network data overview that you can look at. This will be populated again by more sources that as we add things into the Elastic Stack. DNS, HTTP, normal network traffic on your network will be represented here inside of the detection engine. Timelines are a way that you can stitch a lot of different types of data together. And we will explore more about that as we get into actually doing threat hunting and how we can use timelines either directly creating queries or using a drag and drop features and combining events together. Cases are a way that we can create basic triaging cases as you're starting to investigate. They also have the ability to connect to external case management systems that you could use to send data over to them for if your organization uses those for your incident response processes. And then the administration. This is how we will administer the different endpoints, leveraging different parts of it so that we can push policies and configurations to the Elastic Endpoint agents. Again, as we've seen going through this, the security app requires security to be enabled on Elasticsearch and Kibana so that the security data is protected. We haven't done that yet, but just as an overview, this is where those things will be located.